my machine learning project, I've chosen how can AI motivate individuals to fight climate change by letting their lawns grow wild. I have, for a little bit of background here, I have a master's degree in environmental management and sustainability. I've done a lot of carbon sequestration work and a lot of biology work, and I taught biology for a number of years. So this was something that was right up my alley, which I may have to apply later on. So starting off for our opportunity evaluation, the problem. The project topic is how can AI motivate individuals to fight climate change by letting their lawns grow? This involves using AI to provide tailored recommendations for environmental actions, specifically encouraging individuals to let their lawns grow naturally instead of maintaining traditional lawns. I know the United States is huge on lawn culture, but if you want to make that change, your lawn is one of the best places you could start. The presumption, though, here, of course, is individuals have lawns and that they're allowed to let them grow wild, i.e. there's no HOA rules, really nosy neighbors, stuff like that. So this is attractive for an ML-based solution because it is relevant and impact. Right? Climate change is a pressing global issue, and by targeting lawn maintenance, the project addresses a specific, very manageable aspect of this larger problem. Data availability, there is a wealth of data available from various sources such as demographic data, environmental data, local regulations, which can be used to train this model. For feasibility and specificity, the problem is well defined and narrow enough to develop a feasible ML solution. Recommendations can be highly specific to the individual's location, making the solution actionable and practical. So the business understanding, right? The problem definition. The problem, individuals often lack specific localized information about how they can contribute. General advice is usually not applicable to their unique conditions, right? That's the current state. It's both the problem and the state. People don't know. There's vagaries, there's things about like if you live in this state, but nothing about like your neighborhood. So a successful definition would be what's the expected impact of it? Providing a tailored recommendation will empower individuals to take effective actions, thereby increasing their overall impact on carbon reduction. Their outcome metric is a reduction in their carbon footprint, which can be based on total land productivity and carbon sequestration per square meter. There's lots of available data on this from government sources. I used it a lot when I was teaching it and in grad school. There's a whole list that I could put here that I didn't, but there's a lot of it. So our output metric is our mean square error of predicted versus actual carbon reduction actions taken. And our constraints, our recommendations should lead to a measurable carbon reduction within 1 year or through a complete growing cycle, because I know not every place in the United States has all 4 seasons. Sometimes it's just a wet or dry or what have you. So relevant factors, right, to that, local weather and climate patterns, density and type of buildings in the area. My house in the city did have a backyard, but it was very tiny. My house in the suburbs has a very big backyard with not a lot of buildings around me. Extensive tree cover and landscape features. If you have a lot of trees shading your lawn, you can't do anything. Your lawn barely grows to begin with. Local government initiatives and regulations. If you're not allowed to let your lawn grow wild, some municipalities have that where they can't allow it. It must all be cut. Or there are other things about xeriscaping and stuff, which is beyond the scope of this presentation. So our solution and validation plan. So our concept, right? The proposed solution involves an AI-driven recommendation system that uses predictive modeling to suggest specific actions for individuals based on their specific locations. For example, the model can recommend letting lawns grow wild to reduce their emissions, right? That's the validation plan. So our execution, how do we execute this validation plan? So we conduct user surveys to gather initial feedback on the recommendation system. You know, how do you want it? What do you think is going to work for us? Develop a prototype and run some A/B tests to compare the effectiveness of the recommendations. I decided to let the lawn grow. I decided to put xeriscaping in so I don't have to mow my lawn at all. All various things. I decided to use a different type of grass and let that grow wild, etc. So we can collect data on actions taken by users and measure their actual carbon reduction. This would require training, and that's what I meant about carbon sequestration per square meter. It's got a lot to do about digging up the roots and figuring out biomass of plants. That's all like a whole lecture lab. We can iterate on the model based on user feedbacks and their performance metrics that they've gotten from those tests, and other metrics that may present themselves during testing. There are things that might not even be talked about right now, like cicadas showing up and changing the geology of the area. So our ML system design, right, these are key system level detection architecture decisions. Data source integration use a combination of demographic data, environmental data, and local regulations. This will involve integrating APIs from various data providers, like the National Weather Service, the Bureau of Land Management, the EPA, ESRI, which is an acronym, I forget what it means, but that's basically satellite data. Well, it's the algorithm that incorporates satellite data. Graphic Information Systems is a satellite data as well that does things like land slope, water runoff, temperature, like everything you could think of. And there's a lot more there that can be used. So our model choice is opt for a supervised learning approach, potentially using regression or classification algorithms to predict the best actions for users based on their location. The only one I could think of that was effective was supervised learning. This isn't something they could just do by itself. And our user interface, right? We have to design a system so that people can actually use it to say like, oh, this is what my lawn's doing. Here's my data. Here's my feedback. So a user-friendly mobile or web application, I would say mobile because you're going to be out in the field, right? Probably with an iPad or something similar. That delivers recommendations and tracks user actions. To make it easier for the people to use it in the field is the best way we can have them work with the system that we've designed. So potential risks in production, right? There's a lot of potential risks. Training and skewing, and training serving the skew. Differences between training data and live data could affect performance, right? You need to have regular updates. And I mean almost on the course of like days, right? Because this hooks into the latency. The system needs to provide real-time recommendations, so optimizing for low latency data processing is essential. It rained. I need that data like tomorrow, even tonight if it's possible. Data drift changes environmental data like cicadas, or user behavior like not doing anything about cicadas. Over time can affect modeling accuracy. Implementing continuous learning and periodic retraining will help mitigate the risk. Like, are you doing carbon sequestration studies properly? Are you re-engaging properly? And of course, concept drift, right? The relevance of recommendations might change due to evolving environmental policies or new scientific findings. Trees don't actually sequester as much as you would. Lawns don't do this. Fescue doesn't do it as much as Bermuda. All of those idiosyncrasies that lawns can have. Regularly reviewing and updating the recommendation criteria will be crucial. On this, I'd say it's on the level of seasonality. Things don't change so much when you get above certain, when spring versus fall versus autumn. Well, spring to summer doesn't, fall to winter does, right? So it all depends on how you do that. I think that is everything else that I have for this presentation. Thank you very much. I appreciate your time.